Okay, so we're going to work this problem. And we've got, again, some kind of representation of a vehicle with 3-point loads. That's 1 meter apart and then 3 meters back. And it's on the right side moving to the left. And I want to find what the maximum shear at C would be. So the first thing we want to do is draw an influence line for the shear at C. And to imagine that, I'll put my little shearless connector there, and we'll hit it with positive shear on both sides. So what's this left-hand side going to do? This part of it's going to move down or up?
Down.
Down. So it's probably going to rotate like this. So looking at the right segment, this point is going to go up or down? Looks like it's going to go up, so it should rotate something like that. So that's kind of my qualitative feel. And let's go ahead and draw it. So this will be the shear at C. And I'll put these segments in it so I can see it clearly. So my structure, my shear diagram, my shear influence line should look something like that. Now I know this is 2 meters, and I know this is 6 meters. I know these triangles are similar. Right? So let me again come in here and say, what is this height right there, h? So 2 is to h as 6 is to? Well, 6 is 3 times bigger than 2, so this should be 3 times bigger than h. Right?
Yes.
And I know if you add those together, 3h plus h should be 1. So you get 4h equal to 1, so h is equal to 1/4. So that means that this piece at the bottom becomes negative 1/4, and the top becomes 3/4. That's pretty cool. So now I just got to check 3 cases. So let's begin. I'll start over here with case 1. So again, just to make it easier to see, I'll redraw this thing. This is the shear at C. Oh, my line got a little squiggly. Sorry about that. That's a Tennessee road, so the pavement's falling off. So, I'm going to let the first load, my 1 kilonewton load, come out and hit the positive value. Because I'm trying to find maximum shear, it looks like I've got more positive parts than negative parts. So I'm going to assume right now that I think the positive will be better. So that means I'm going to let that first load stop right there. And then 1 kilonewton back, 1 meter back is the 4 kilonewton force. That's at 1 meter. And then 3 meters back from that is the bigger of the set, the 6 kilonewton force. So I need to find 2 additional values off my graph. I know this one is 3/4. Right? What's the slope of my line? Well, it's 3/4 to 6, right? So rise over run, which is 3 over 24, which is an 1/8, right? Is that right? So that means every meter I move to the right, I drop an eighth. So I move 1 meter, I drop an eighth. So this is actually 6/8. 6/8 minus an eighth is 5/8. And then I move 3 more meters, I should drop 3/8. So 5/8 minus 3/8 is 2/8. And now all I have to do is add them up. So the shear at C for case 1 will be 1 kilonewton times 3/4 plus 4 kilonewtons times 5/8 plus 6 kilonewtons times 2/8. What's that equal to? $4.75. I'm just guessing. That's not right.
What'd you say?
I said 4.75. Is that what it is? That was an educated guess. Everybody good with that? It's really gotten quiet in here. You guys are usually a lot more excited, especially when we're getting close to a holiday. By the way, I'm going to give you homework over Thanksgiving. Maybe a double dose, a little special festive homework. I want to make it due Thursday at noon. No, I'm kidding. I just want to see if I get a reaction. I'm getting nothing from you guys. All right, so let's do the next one. Case 2. I don't know why I put it over here. I just am. All right, so let's redraw it again. You can see that we probably spend more time redrawing the line than just about anything else. But I think that helps you kind of visualize it. Okay, so now the second case, we're going to take our second wheel load, the 4 kilonewton force, and it's at the top. 3 meters back is the 6 kilonewton force, and 1 meter forward is the 1 kilonewton force. So I've got, again, 3 values to compute. This one we know is 3/4. We've already got the slope of the right-hand side. It was 1/8. So if I move 3, that means I'll drop 3/8. This is 6/8 minus 3/8 is 3/8. Now we don't know the slope of this side. We haven't looked at it yet. But I know it has a rise of 1/4 over 2. Look at that. It's the same. So these slopes are going to be the same. So since I'm moving 1 meter, I'm going to change 1/8. I started off at 1/4. 1/4 minus 1/8 is 1/8, and this is negative. Everybody see those values? Now all you just do is add them up. So the shear at C for case 2 will be 1 kilonewton times minus 1/8 plus 4 kilonewtons times 3/4 plus 6 kilonewtons times 3/8.
So when
Yeah.
you're going back, when you're looking at the other triangle, we're not worried about that 3/4 that we have in the other one.
It's moved, right?
I'm saying, I was thinking for a second, when you found that slope, I don't know why, I was thinking you were gonna like subtract from that to when you go over, but you don't even worry about that. You just
I'm
worry about-
going to use the slope to find out, predict this value off the curve.
Right. I see.
What is that going to be? That's 18/8 and 24/8. I don't know what that is. 5 and an 8. Is it positive? Are you sure? 5 and an 8? That would be 5.125.
Yeah. I got 3.6.
You got 3.6.
No, 5.125.
I don't think that's right, because I know 3/4 of that, that's 3. This term here is 3. And then that's almost a half. That's 2 something. 3 and 2 is 5. So yeah, it's not 3. This is only minus 1/8. So that's kind of interesting. This one is bigger. Would you have predicted that? That's where the prediction gets a little murky. And I think it's best just to go ahead and check it. Final one would be case 3. Again, just give me a little second here to re-sketch this. Again, we're doing the shear at C. So in this particular formation or position, we're going to let the 6 kilonewton force be at the top. And then 3 meters in front of it is the 3 meters. We're off the structure.
Yep.
So that's an easy one. So the shear at C for case 3 is just going to be 6 kilonewtons times 3/4. Which is 4.5. So what's the maximum value? Looks like case 2. So the shear at C would be 5.125 kips, which is when the second load is just to the right of C. Very doable for the exam. Again, that only took us about 12 minutes. And that's with all the discussion involved. So it's not bad.